Hello, my name is Brian Raux. I'm a medical science liaison with Biomerieux. In this chapter, we'll be discussing how antimicrobial resistance has changed during the pandemic and how locally institutions are able to sort of track their data and what they can do with it from there. So here we'll start diving into the continued growth of antimicrobial resistance from antibiotic use and misuse throughout the COVID-19 pandemic. In July of 2022, the CDC published a special report on the impact that COVID-19 has had on antimicrobial resistance in the United States. One of their major findings was that the detection and reporting of antimicrobial resistance data slowed tremendously over the previous 2 years. CDC's Antimicrobial Resistance Lab Network, which is a series of 7 labs spread throughout the United States, received and tested 23% fewer specimens or isolates in 2020 than they had in 2019. PulseNet, which looks at gastrointestinal bugs via the National Antimicrobial Resistance Monitoring System for enteric bacteria, analyzed 21% fewer genomes than in years past. For both of these, it's a combination of fewer isolates being sent, but also resources being reallocated to analyzing COVID genomes and the impact that it had on patients throughout the pandemic. In 2019, we received the updated CDC antibiotic resistance threats report that had 18 antimicrobial resistant threats or pathogens. For 9 of those 18, we actually don't have enough data to know what has been going on with regard to their threat level, and those are listed on the top section here of this graphic. The bottom section tells us for the organisms that we do know about, for 8 of those 18, resistance rates are rising quickly. Anywhere from 13% for methicillin-resistant Staph aureus to as high as 78% increases in the number of resistant hospital-associated infections caused by carbapenem-resistant Acinetobacter. National data are alarming. So locally, we need to know what's going on in our hospitals. Antibiotic susceptibility testing data flow from the laboratory instrument into the laboratory information system, and finally into the electronic health record, and maybe a clinical decision support software, or CDSS. Each of these systems is able to create an antibiogram. Each option, though, has its pros and cons. Data are censored as they move from the lab instrument over to the electronic health record, whether that be suppressing or sort of optimizing what the clinician ultimately sees so that they can make the most appropriate decision. The data access level is different based on who you are, whether you work in the lab or maybe you're a pharmacist that only has access to the electronic health record. If you think about the customizability, whether or not these systems were actually designed to create antibiograms, or is the software just actually there to collect data for patient care, and we're looking at it retrospectively to make these decision tools for our providers. In a similar vein, whether these are for static or rolling production, can you just ask the software and say, hey, show me what's happened for the last 12 months? Or instead, is it a big to-do that your hospital does once a year and quickly becomes outdated? The CLSI, or Clinical Laboratory Standards Institute, updated their M39 document earlier in 2022. This document provides recommendations on how institutions can prepare their local cumulative antibiograms. We're not going to go through all of the different updates that they made, but 2 in particular that I want to highlight are practical concerns and some of these advantages and disadvantages in extracting your data from the different data sources that are available, and then also how you can combine results from rapid diagnostics and resistance markers that maybe you get before your full susceptibility. How do you incorporate those into your antibiogram? So along with all these advantages and disadvantages, there are systems that are available that, if given access, can collate your data from the lab instrument, the laboratory information system, and the electronic health record. There's no such thing as a free lunch, though. With this additional capability, there tends to come an additional cost. Healthcare systems need to strike a balance between increased flexibility, knowing all of the information about not only the isolates, but also the patient, and how much time and money and effort will be spent. So thank you for joining me for this chapter where we talked about how antimicrobial resistance has changed throughout the pandemic and how institutions can look to do new and improved local antibiograms. In the final chapter, we'll be looking at staffing shortages and how institutions can employ a syndromic approach to do more with less.